Okay, probability distributions and frequency tables. Essential questions, pretty straightforward. Just explain in detail how you would create a frequency table, which technically we actually did last time, but you just didn't know that it was called a frequency table. Okay, there's 3 vocabulary phrases we need today. First, starting with what was that frequency table? Frequency table. Okay, a frequency table is a data display that shows how often an item appears in a category. A data display that shows how often an item appears in a category. What experiment did we do last time in class on probability? The dice. Was there a way we kept track of how many 1s and 2s and 3s, 4s, 5s, and 6s we got? Yeah, it was just a table when we just did some little check marks. That was a frequency table. Oh, so hard. Okay. So we've already done one of those. Okay, next. There's 3 vocabulary phrases. Relative frequency. We'll be working with today. Relative frequency. Oops. Relative frequency is the ratio. A ratio is oftentimes written as a fraction, okay? So it's a ratio of the frequency of the category to the total number of the frequency. Ratio of frequency of category divided by the total frequency. Frequency of category divided by the total frequency. Relative frequency essentially will be answering our question. Okay, what's the relative frequency that we roll a 4? Well, then we just go over to our little table and see how many 4s we rolled out of the 50 times we rolled the die. And the last one is the probability distribution, which technically we did last time as well. You just didn't know that it was called probability distribution. Okay, it shows the probability of each possible outcome. Shows the probability of each possible outcome. And this can be displayed on your frequency table. Probability distribution shows the probability of each possible outcome can be displayed on a frequency table. You show him, Ms. Bergstrom. Okay, we're just going to do one example. I think you'll get it, though. It's pretty straightforward. So, example 1, if a coin is flipped or tossed 3 times. let's see. We're going to write the probability distribution and, sorry, I'm on the wrong page here. What was the question again? Yes. What is the probability that exactly 2 heads will occur? What is the probability that exactly 2 heads will occur? Well, we're going to flip the coin 3 times. 1 coin flipped 3 times. So let's make a list of all possible outcomes. And then, whoops, line. Maybe. Let's try it. I'll make 6 spots and see if they come up with more or less than that. 3, 4, 5, 6, and I think one of these is slanted. All right. If we flip a coin 3 times, what's one result we could get? Heads, 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 right? What's another result we could get? Tails, tails, tails. Yes, please write it. Okay, we could get, yeah, I guess I'll just write it right here. Tails, tails, tails. Okay? Heads, tails, heads could come up. What else could come out? Okay? Tails, heads, tails. What else? We could get a heads and then 2 tails. Tails and 2 heads. Okay, that makes 6. Is that it? So we could get 2 heads first, and then tails, or T. We already have THT. Maybe we don't have THT. Do we not have THT yet? Oh yes, yes, I see. But the one missing I think is tails, tails, heads, right? So there's actually 8, and you can actually figure this out. It's called a oh, I just lost it. What's it called? You're in junior high. It's called the fundamental counting principle. Okay, you flip 1 coin 3 times. So here's our 2, 3 flips. The first coin has how many options? And then the we're only flipping 1. Sorry, I'm doing this backwards. 1 coin 3 times. And then this one has heads, tails. The second flip can get heads, tails again. And then we can get, I'm going to run into that, heads, tails, heads, tails, heads, tails. This is called a tree diagram. 1, 2, 3, 4, 5, 6, 7, 8. Okay, the first option had 2 choices, heads or tails. The second option had 2 choices, heads or tails. The third flip had 2 choices. What's 2 times 2 times 2? 8. So it's called the fundamental counting principle. That can help you figure out how many categories there will actually be. Okay, so say we do it. And heads, 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 our frequency. This is the coin toss results. And this is our frequency. Table should always be labeled. We get 5 heads, heads, heads. We get 10 tails, tails, tails. HTH. 6 heads, tails, heads. 9 tails, heads, tails. Also 9 heads, tails, tails. 2 and heads, heads, tails would be 7. So how many times in total did we do this experiment? Oh, the one that has the tree written all over it. Sorry. I have to erase that. Okay, tails, tails, heads. There it is, 2. All right, so how many times did we actually do this experiment? 5 plus 10 is, plus 6 is, 50. Okay, kind of like we did it last time. We rolled the dice 50 times. Okay, we're going to first answer the question, what's the probability that we get exactly 2 heads? This is relative frequency. Okay, does this one have exactly 2 heads? Heads, heads, heads. Is that exactly 2 heads? Does this one have exactly 2 heads? Does this one have exactly 2 heads? Yes. Does this one have exactly 2 heads? Yes. Okay, so add them up. How many had exactly 2 heads? Probability of exactly 2 heads was 6 plus 2 is 8 plus 7 is 15 out of 50, which I believe simplifies. Diana A, what divides into both 15 and 50? Good, so when we simplify, dividing top and bottom by 5, what do we get? 3/10. Does anyone know that as a percentage? Because sometimes percentages make more sense in our head. 30%, because we can write probabilities in 3 ways: fractions, decimals, or percents. So 30% of the time we got exactly 2 heads. Look at the wordage. Exactly means only 2, because did we count the 3 heads? No. So this is a different wordage. What's the probability that we get at least 2 heads? Let's find that one. Does this one have at least 2 heads? Does this one have at least 2 heads? 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 Okay, so actually there's only one additional one. So we have the 15 plus the 5 makes this probability, relative frequency, 20 out of 50, which is 2/5 or 40% exactly. When you change the wordage, your probability changes. Now what's the probability that we have less than 2 heads? Can you do that without actually adding them up? If we know at least 2 heads is 40%, less than would be 60%. So that would be the remaining 30 out of 50, which is 3/5 or 60%. So careful on what the wordage actually is. Exactly must be exactly. At least must be equal to or greater. Less than is up to, but not including being equal to. Okay, so this is called relative frequency. Any questions on relative frequency? What we did above right here, this was the frequency table. You know already how to do those, you just probably weren't aware it was called a frequency table. Lastly, the last thing we need to add in is the probability distributions, which I'm going to, I didn't leave myself room. Maybe if I just erase these smiley faces and the stars. Probability distributions is just to find the probability of each individual column. Probability distribution. Okay, what's the probability out of the 50 that we, if we recreated our experiment, what's the expected probability that we get heads, heads, heads?
45.
What? Yeah. How many times do we get heads, heads, heads? 5 out of 50, which actually simplifies. I'm going to write it smaller. to 1/10. Remember, this is experimental probability, which is different than theoretical probability. On a coin, theoretical probability means you should get each side 1 out of 2. Okay? We haven't yet this year calculated how we get given a heads, that we get a second heads, that we get a third heads. That's a more complicated probability. This is experimental probability because it's based off of the results of our experiment. If we were to recreate our experiment a second time, we would expect to get tails, tails, tails. How many out of the 50? 10 out of 50, which would be 1/5. So these are the probability distributions. Okay, heads, tails, heads. 6 out of 50, which simplifies to, let's see, they're both even, 3 out of 25. Okay, the next one, Nemo. Does that one simplify? Nope. This one matches exactly, 9 out of 50. Okay, Brayden, what's tails, heads, heads probability? How many times do we get tails, heads, heads? Good. Does this one simplify? They're both even, so they both divide by 2. What's 2 divided by 2? And 50 divided by 2? There you go. So that's actually the same as this one. And lastly, 7 out of 50. Okay? Relative frequency, probability distributions, and frequency table. Is there any questions? Okay, reminder on your homework. Sorry. We're going to still do that blue packet. You're going up through 10. So 1 through 10. Guys, remember, pre-show work. You'll be checking that off. And our assignment starts for this, which I'm keeping it short because I understand you have the blue packet still, is, this is the wrong book. Sorry, the wrong book. My book has different pages than your guys', so I have to look in yours. Here it is. Page 933. No, but this was short. 1 through 12. They go pretty fast.